Okay, so the key to solving any equations really is to try and make use of our null factor law. So it's really the same principle as with our quadratics. I guess with our quadratics, we might have had something like that, just x plus 1, x plus 3 equals 0. So we know x is equal to -1, -3. Obviously, if we've got a cubic, typically we're going to end up with 3 factors. So the key is to try and get it into this factored form. If it's not, we have to get it there like we will have to do with part B. If it's in this factored form, our null factor law says that either x minus 2 has to equal to 0, or x plus 1 is equal to 0, or x plus 3 is equal to 0. So we're just going to have x will equal 2, -1, or -3. So what we're saying here, in other words, if I substitute 2 in, or if I substitute -1 in, or I substitute -3 in, the answer will be 0. They're the values that make this equation equal to 0. All right? So with question B, it's not in a factored form. So we've got to try and go through our division process to try and get it down to a factor and a quadratic factor. So remember, with our remainder theorem, if I can think of a number, so we'll call this function p of x, and we'll make it x cubed minus 4x squared minus 11x plus 30. So now the first answer is going to be a value that I can substitute in to get 0. So our immediate reaction is to go for a plus or a -1. But if we look at these coefficients, I've got a 1, -4, -11, and 30. I'm not going to be able to add and subtract any of these numbers here to cancel out with a 30. So I know one's not going to work. So I'm going to start with plus or -2. I'm a chance for one of those to work. So let's just go. I've got a couple of negatives and a big positive there. So let's try with a +2. So if I put p of 2 in, I get 2 cubed minus 4 times 2 squared minus 11 times 2 plus 30, which is equal to 8. 2 squared is 4. -4 times 4 is -16. Minus 22 plus 30, and that does equal to 0. So because that's equal to 0, x minus 2 is a factor. Okay, and because that's my factor, I can now do my division. So my division, remember, I'm going to use that synthetic division. X minus 2 is a factor. Coefficient is 1, so that's no issue. I'm going to put a 2 down there. My coefficients of my polynomial are 1, -4, -11, and 30. So I'm going to go through the process. I'm going to bring the 1 down. 2 1s are 2, add them together. 2 -2s are -4, add them together. 2 -15s are -30, add them together. So if I've done it right, I get 0, which I have. So that means my answer is a 1x squared minus 2x minus 15. So this polynomial here, I can now rewrite as x minus 2 out the front, and an x squared minus 2x minus 15. So what I want to do now is factorize this quadratic expression here, okay, to make it linear. So x squared minus 2x minus 15. So I need the factors of 15 that add up to -2. So if I go for -5 times 3, that adds to -2. So I'm going to be able to write that as x minus 5. I don't know why I said a 2 there. X minus 5, x plus 3. And I've got already my x minus 2. And don't forget, from the question, I'm trying to solve this equal to 0. So clearly now I can see x is equal to 5, -3, or positive 2, okay? So let's have a look at the other couple of examples. The first step of any factorising is always to look for any common factors. So in this case, if I took x out the front, I'd get 2x squared minus x minus 1. So let's try and factorise that quadratic. If I go 2x and x with a negative 1 and a positive 1, so that's going to give me 2x times negative 1, which is negative 2x. X times 1 is positive x. Add them together, I get minus x. So that means that bracket there, I can now factorise my equation as x. And then the parabola that I've got left is the same as 2x plus 1, x minus 1, and that's equal to 0. So now I can see clearly I've got x is equal to 0, 2x plus 1 is equal to 0, which means x will equal negative a half. X minus 1 is equal to 0, so x will equal 1. So they're my three solutions. So I won't always have to do a division if I've got a quadratic, a cubic I should say. Look to take a common factor out first. So if I do the same thing again here with b, I've got x is common. I've got x squared plus 2x minus 10. So I need to try and factorise that quadratic term. Let's think about that. What have I got? I've got minus 5 plus 2 doesn't work. So the factors of 10 are just 10 and 1 and 5 and 2, aren't they? So that's not going to factorise by inspection like that. So my choices are complete the square, use a quadratic formula, okay, to try and solve this expression equal to 0. So I might do it in two different ways here just to show you your two approaches you can use, okay? Approach 1, I'm going to complete the square, which means I'm going to write that as x squared plus 2x, halve it and square it, minus 1 squared minus 10. So I can write that as x plus 1 all squared minus 1 minus 10 minus 11. So I've got to solve that equal to 0. So then if I take x plus 1 squared is equal to 11, x plus 1 is equal to plus or minus root 11, so x is equal to negative 1 plus or minus root 11. So there are two of the solutions. The third solution is over here with x equal to 0. Okay, so there's my three solutions. Or I can see x is equal to 0. If I use the quadratic formula on this, I get a equals 1, b equals 2, c equals negative 10. So x is equal to minus b plus or minus the square root of b squared minus 4 times a times c. All over 2a, which so x is equal to minus 2 plus or minus the square root of, what have I got, 4 plus 40 is the square root of 44 over 2. So 44 is the same as 4 times 11. X equals minus 2 plus or minus, root 4 times root 11 over 2. Square root of 4 is 2. Minus 2 plus or minus 2 square root 11 on 2. They all cancel. I get x equals negative 1 plus or minus root 11. So again, there's those two solutions with also x equal to 0 as the other one. So don't forget that because we're looking for solutions, for the most part, we're looking for solutions. So you don't necessarily need to to factorize. We just want the solution to it. So if you're not great with your factorizing your quadratics, just be an expert at the quadratic formula. Make sure you can use that every time and get it right every time. Okay, and that'll serve our purpose. All right, so let's have a look at. Let's just get ourselves a bit more. Geez, we haven't got much room there, boys. Okay, sometimes look if you can see little patterns, and often we'll give you that little hint. You can see there that it says try to use grouping. So what that means is sometimes when you've got a cubic, you can make pairs to factorize by the pairs. So if you have a look at this one, it normally works. If I look at all of these coefficients, I've got 1, 4, 11, 44. Notice how the 1, 4, 11 are all factors of 44. So when you've got that sort of relationship, often you can factorize by grouping. What I mean by that is treat them as a pair, treat them as a pair. So if the first, I take an x squared out, that leaves me with x minus 4 there. And if I take negative 11 out the front there, I get x minus 4 in the second bracket. Okay, so that's equal to 0. So now x minus 4 is common. And the other bracket will be x squared minus 11, all equal to 0. So now I've got it factored. I've got in here x squared minus 11, which is a difference of squares. So I can write that as x minus 4, x minus root 11, x plus root 11. So therefore my solutions are going to be given by x is equal to 4 and x is equal to plus or minus the square root 11. Okay, so sometimes we get lucky. Just because we have a cubic, we don't always necessarily need to go through the whole division process. But to be honest, most of the time we do. The last one, again, 1 times a times 11 is 11a. So, same sort of thing. If I take x squared out the front, I get x minus a. Minus 11 out the front, I get x minus a. X minus a is common. I get x squared minus 11. They're all equal to 0. So if I slightly different, x minus a is equal to 0. X squared minus 11 is equal to 0. I get x is equal to a. X squared is equal to 11, which means x equals plus or minus the square root of 11. Okay, so the solving part of it, once you get it factorized, should be okay. Getting it factorized is the key. So for the most part with our cubics, if we have a look down, we may need to, we've got to get it into this form here that we've done in A. So get it into this form, okay, which means here we might need to have to go through that whole division process, all right? Sometimes we get lucky and we can factorize grouping or by just taking out a common factor. But this is where our factorizing by factorizing quadratics will have to be strong, all right? So practice some of this.